Hi, I wanted to go over sets and subsets for a real number system. You know, we've got these silly strategies we love to say, and I thought I should film them so we remember next year so I don't forget. So, here we go. We all know, how do we remember that? My class should know. How did y'all learn that? Yes, you're right. Never write in red ink. So, I've got never write in red ink. So, what does that mean? Besides never write in red ink. How about natural, whole, integer, rational, and irrational? Make sure you're taking good notes. So how do y'all remember which set is which? You know, if you go back to that video I was playing for y'all, you know, natural numbers are numbers you count on your hands and your feet. And that was 1, 2, 3, and so on. So on. What about whole numbers? So what about the word whole right there in the word? I think that's a good hint. So we'll start with a whole. 0, 1, 2, 3, and so on. One of the kiddos in class said they like whole numbers. I thought, really? They go, yes, they do. I thought, well, what's that for? And they said they like donut holes. I thought, well, that's pretty cool. Donut holes. Perfect. What about integers? What's an integer? Me personally, I see that as a number line. So I'm thinking number line. So and that was a donut. So wouldn't that be -2, -1, zeros, ones, twos, and all those numbers on each side? For sure. What about rational? What's a rational number? Fractions. Both kind. Mixed number. What about 4? What about -3? And those are all from this grouping up here, including these fractions. What about decimals? 3.2. But what about 3.72 repeat? Would 3.72 repeat be part of rational? Or would it be part of irrational? Good questions. These are good questions. You could even stop the video and think about that. So how about some hints? That starts with an R, doesn't it? Sure it does. Now, how about R for repeats? So we could definitely have anything that repeats in this category. R for repeats. So then that is acceptable. Have you looked at the word rational? Have you seen the other word in rational? Like ratio, possibly? If you look at the word rational, I highlighted, or try to, the word ratio. All of those numbers in this category are ratios. So what's a ratio? Comparing two things? What's another thing that compares two things? Yes, fractions. So then this whole category is a ratio. They're fractions. They compare two things. Perfect. Now, if that's true, if rational is a ratio and rational is a fraction, then what's irrational? Wouldn't that be not rational? So if it's not rational, let me scoot my paper over for you. Because didn't we do R for repeat? So wouldn't this be not repeat? Good point. By the way, they're not fractions. It's not a fraction. It's not a ratio. It is those weird numbers that just don't like to play nice. They don't repeat. They don't stop. They just go on and on and on. So if I take this number 3.24781, on, you know, it's going to go forever. I'll die before that number will, because that number's alive. It will live way past me. It doesn't end. If you've ever had homework for division, and you were dividing, and it just wouldn't stop, and you carried it out to 12 places, and you finally just gave up. You know, and you brought your paper to class, and you were just all upset with those answers because you just finally gave up and couldn't figure out why it wouldn't stop. Were you dealing with a rational number or an irrational number? Irrational, because it didn't stop. Now, if you'd have stopped and read the directions that said round to 2 places, that might have helped a lot on that homework. But nonetheless, if you're working with that kind of a number that won't stop and doesn't have a repeat, no pattern, you're working with an irrational number. That was the purpose of the directions, to round to 2 places. Well, I hope you enjoyed my video. Again, that was never right in red ink. And this side here are all rational. They are fractions. It's a ratio. These are not rational. They're not fractions. They're not ratios. They don't repeat. These do. These go on and on and on. What would both sets together be called? Correct. The real number system. So if you go back to my title, get that paper to move. There it goes. Real number system. So both sets are the real number system. Would there be a different type of number system? Yes. There's an imaginary number system, but that's in high school. Alrighty, I hope you enjoyed my video. Good night.